Alrighty, Brendan from WPSpeedFix here again. We're going to talk about time to first byte in this video, how to reduce server response time or improve your TTFB time to first byte on WordPress. So let's get into it. So I have some notes here. We actually have an article on our website already about this topic here, but we're just running through and updating it for a couple of clients. We had some discussions about time to first byte with, so I thought it would be time to make a video. So let's talk about it. What is it? So TTFB is time to first byte. It is a measure of how fast or how quickly your website or hosting responds to requests. So you send a request and how long it takes to get the first byte back from that request. That's time to first byte. So there are actually a lot of things. There's a lot of component parts that make up time to first byte, but bad TTFB means everything else on the website will be slow, because if the server is slow to respond, it doesn't matter how optimized your theme is or your CSS or JavaScript or whatever. If the hosting is slow to respond, everything else will be slow. So arguably, time to first byte is one of the most important speed metrics. It's not a core, it is a Web Vitals metric, but it's not a core Web Vitals metric. So the three core Web Vitals metrics are LCP, INP, and CLS. But if the time to first byte is bad, then those other metrics will probably be bad, especially the LCP. So we did a video, the last video we did on our channel was about LCP, and we talked about checking the LCP metrics to see if the problem was actually, or the root cause of poor LCP time is actually poor time to first byte. So we thought we'd do this video next. There is actually this article on Google. Actually, I should copy that and put that in here in the notes. There is this article here that's actually really technical and good and digs into all the component parts there. You can see there's the bits and pieces that make up the time to first byte, but it's kind of got a good summary here. So time to first byte is some of these. How fast any redirects are. So if you're redirecting from the URL you type in to the final URL, for example, if you type in WPSpeedFix.com in your browser bar, that has to redirect to SSL, so HTTPS, and redirect to www.WPSpeedFix.com. So that's redirect time. Service worker startup, that's not really appropriate for a WordPress site in this kind of scenario. DNS lookup time, so that one's really important, and we'll get into that in a moment, but slow DNS hosting means your time to first byte will be bad as well. Connecting to the server and negotiating security, SSL encryption, and then the processing of the request by the hosting or the site or WordPress and getting a response back. So there's several parts that make up time to first byte, and we'll talk through those. In terms of what good TTFB is, under 800 milliseconds, so you can see that that's the good zone. Needs improvement, 800 milliseconds to 1800, so 0.8 of a second to 1.8 seconds, and then anything over 1.8 seconds is bad. This is kind of the limiter to load time. So your site can't load any faster than the time to first byte, essentially. There are some exceptions with caching and things, but as a general rule, if your time to first byte is 2 seconds, then your site can never ever be faster than 2 seconds. So it's really important that this metric is good and your time to first byte is low, and you reduce it as much as possible. So that's time to first byte. The other thing, time to first byte is really bad for SEO. So core vital stuff aside, if the server or hosting is slow to respond, then when a crawler comes along to crawl the site, it's going to get the same slow response time. So if you have, say, 100 pages on your site or 1,000 pages, and they all have bad time to first byte, then crawlers are quite often going to give up, or they'll get timeouts and won't be able to crawl the site properly. So there are downstream effects of bad time to first byte on SEO that sit outside core vitals issues. So typically when we see a site with bad time to first byte metrics, the SEO will usually be poor or not as good as it could be. It's kind of like a rate limiter on SEO. So when we see sites with poor time to first byte on WordPress, it is because either caching is not working, it's not working correctly, or the request is being made to something that's not cached. Oops. Like a search page. So if you search, that's not a cached page by normal. A checkout, a login page, anything like that is a page that has to do processing. So that'll have a higher time to first byte because that's relying much more on the hosting and the configuration. or whatever that page load is doing, it is bypassing the caching. So this is a very common scenario with paid traffic where you are using a click fraud tool or some sort of tracking tool that adds a query string onto the end of the URL to track stuff. By default, that query string will make the page bypass all the caching. So the caching will not work for that individual session or page load. And that's one of the most common reasons why we see poor time to first byte. So if you have paid traffic and you have this issue, then those users or that subset of users will have a high time to first byte, which is also bad from a paid traffic perspective because that's arguably some of your most expensive traffic that is getting the slowest user experience. So it's really important if you have paid traffic that you pay attention to this metric as well. So that's kind of an overview. There is a lot more on that article. So if you want to get into the tech stuff, that'll explain more. Now, before we do anything, as always, we want to look at some numbers. The worst thing people do with speed optimization, and the biggest mistake, is start firing off optimizations and changes without understanding the number that they're trying to change. Now, we've talked about before in many of the videos that PageSpeed Insights or Google Lighthouse is the wrong tool to really use when you're working on core web vitals or site speed. The reason for that is because that is a synthetic or lab test. It's trying to approximate what's happening in the real world. Core Web Vitals data is actually the real world traffic. So it's real users on the site, and Google is grabbing that data from Chrome-based browsers. So that's the data we want to look at. That's the historical data. So there's two tools here I've got for you. One is a very technical tool, Google's CRUXVIS, and the other one is ours, which is a bit more of a simple tool. Now I have a site here, example, that has bad time to first byte. So I have just run a report. This report takes 5 seconds to run. No opt-in required. I've just run it here, and you can see the time to first byte is bad. So it is 3.1 seconds for the average of the 75 percentile users are getting. So that's bad. So 3.1 seconds. So approximately 50% of users are getting good time to first byte, so under 0.8 of a second, and 50% of users, or 45%, are getting bad time to first byte, so over 1.8 seconds. So that's not ideal. And usually when we see data like this, when we see a half red and green, it usually means there's a specific technical problem to solve, as opposed to something a bit more like this, where it's mostly green, some yellow, and some red. So when we see it like this, there is something wrong. Caching is not working for a particular reason. You can see that FCP time is going to be poor. That's when the site starts to render, and then LCP time is poor as well. That's when the site is finished rendered. And like I said, in most cases, these numbers, FCP and LCP, can never be lower than the time to first byte. Now, there are some scenarios where that's not true, but as a general rule, if this is 3 seconds, this can never be under 3 seconds. So in this case, to make this site faster, we need to fix this problem, fix this poor time to first byte. I hope that makes sense. If we scroll down, we can see the historical speed here. So we can see it's been like this for a while. So it got worse in October. So we went from kind of 2.5 seconds to 3.5 seconds, then back down to 2.5 seconds in January, and it's creeping back up to 3 seconds. So something is up there. So that's our tool. That's completely free, no opt-in required. CRUXVIS pulls on the same data set, but it's much more technical. So you can see here the same graphs, they're going up and down. So you can see here, I think we did another video, we use this as an example. When these two graphs match, you see LCP and time to first byte match nearly exactly. So this bad LCP time is actually because of the bad time to first byte. So we need to fix that. So before you start, run these reports and get into this. It doesn't have it in CRUXVIS, but there are component parts, like I said, of the time to first byte, and one of those is DNS lookup time. In our Vital Signs Tracker tool, we do track that. So if you really want to get into detailed technical stuff around Core Vitals tracking, especially time to first byte, our Vital Signs Tracker tool will do that for you. It tracks every session and it will give you that data. Okay, so let's talk about fixing the bad time to first byte, or improving it, reducing server response time, as it says in Google Pagespeed Insights. So let's just run through this list quickly. So you need fast DNS hosting. Ideally, we would recommend Cloudflare, but this list here, dnsperf.com, this continually tests DNS hosting providers worldwide, and it gives you the speed here. So if you're on a bad DNS host, it'll be slow. So you can see here Cloudflare is generally number one or the top 3 in the world. So its average query response time is 11 milliseconds. And you can see these guys down at the bottom are 136 milliseconds, so 10 times slower. Quite often we see an issue with this if you're using the inbuilt DNS hosting that comes with your domain registrar, or your IT company is charging you for DNS hosting and they're doing it themselves. The main reason why the DNS hosting would be slow is because there's 2 DNS servers. If you use one of the providers on this list, they use something called Anycast DNS, where it's kind of like a content delivery network for DNS hosting, where there are hundreds of servers that respond to DNS requests. So you make a request, DNS request, and it's answered by the closest server. So that's why these guys are faster than a slow DNS provider, because of that Anycast and because they have good infrastructure. But we'd say use Cloudflare, and we'd recommend using Cloudflare CDN, but Cloudflare is generally the fastest in this list. I won't go on about that too much for the sake of keeping the video short. You need a good host that supports HTTP2 and HTTP3 protocols. So these are the protocol that the web browser uses to connect to the hosting. HTTP3 is newer. There is also version 1.1. That is the old protocol. So version 2 will be it'll be faster from a time to first byte perspective, but an overall load time perspective, HTTP2 will generally make the site load 50 to 100% faster than HTTP 1.1. But bottom line is you need a good host, and it needs to support, ideally HTTP3 protocol. There's plenty of checkers around the web. Just search HTTP2 checker in Google, HTTP3 checker in Google. If your hosting doesn't support one of these protocols, or HTTP3, log a ticket with them and ask. These are modern protocols, and all hosting should support it. Again, if you have Cloudflare, it adds that support, but your host really needs to support it for maximum speed. You need an SSL certificate, goes without saying. On a modern web, everything should be secure, and you cannot use these 2 protocols if you don't have SSL in place. So that's pretty straightforward. I don't think we need to say any more there. You really want HSTS enabled. So this is a header that comes along with the website that tells the browser it can only connect to the server via SSL, via secure connection. The reason why this is better is because it avoids making HTTP requests, unencrypted requests, which are slower because they can't use these protocols. So this will generally speed up or improve the time to first byte for the second visit or repeat visitors. But broadly, it's good practice, but it will help improve the time to first byte. It will not be the root cause of really bad time to first byte, but it is an optimization you should have and should be enabled. And there's a video on our website, on our YouTube channel, about enabling HSTS in Cloudflare. You also want a 301 redirect from all the variations of your website address to the primary one. So HTTP to HTTPS, and no www to the www version, or the opposite, whichever is the default for your website. But you need those redirects in place, and ideally we do those redirects at the Cloudflare level. So we're using Cloudflare for content delivery network, we're using Cloudflare for DNS, and the reason why we do it at Cloudflare is because it's faster. If you don't do it at Cloudflare, I'll just write, failing that, do it on the web server. If you don't do it in any of those places, if you don't do it at Cloudflare or the web server, you're leaving WordPress to do it. And WordPress built-in redirects are slow because they're relying on PHP. So just keep that in mind. It'll be fastest to do it at Cloudflare. So do that if you can. Here is an important one that we don't really see anyone talk about, but quite often we see websites where they have internal links that are pointing to the wrong web address or slightly wrong web address. They are pointing to the version of the web address without a www, or they're pointing to web addresses on the site, particularly in the menu, without a trailing slash, where the default for the site is to have a trailing slash. So for example, if I was talking about our website, we'd have, our default is to have a trailing slash. So just page trailing slash. If we had menu items without this trailing slash like that, then there's going to have to be a redirect to this version of the page. So you want to do a crawl using an SEO tool and make sure that all your internal links are pointing to the right URL. So in our case, it'd be HTTPS www.wpspeedfix.com. If we had, HTTP here or without the www, a redirect has to happen in order for the actual page to load. So just keep that in mind. So it's kind of good hygiene and good SEO to fix that, and it won't really affect the time to first byte metrics per se in Core Vitals, but it will impact the user experience because they have to go through redirects to load a page. I hope that makes sense. Okay, next one, you got to use caching. So the two caching plugins, we use WP Rocket, so wprocketplugin.com or flyingpress.net. I won't go into that too much. If you're watching this video, you probably know what caching plugins are. If not, you should have one of these. Go check them out. We have videos about those separate on our channel. Okay, these two, you want to get a CDN in place. So we recommend Cloudflare. It's the biggest CDN in the world. It's easy to set up. It's SEO friendly. The main benefit here from a time to first byte perspective is twofold. One of them is you're moving the workload from the hosting onto the CDN service. So a lot of the file serving gets done by Cloudflare instead of the web hosting, which frees it up. So you've got more juice, more CPU power, more processing power, whatever. And you want to use edge caching. So what edge caching it is the pages themselves, not just things like the files, images, CSS, JavaScript. The pages themselves are cached at the Cloudflare layer. So almost the entire site is loading from Cloudflare. Cloudflare's service for this is called APO. So it's $5 a month or on the $25 a month plan. Flying Press also has a version of APO it can do with Cloudflare without a subscription. So if you have a tiny website and you don't want to spend $5 a month, then get the Flying Press plugin and it will do it for you. The Flying Press plugin, I think off the top of my head, is $59 a year. So you would save that $5 a month and get all those speed optimization features with the plugin. But bottom line, you want to have edge caching in place. On the modern web, it really helps a lot with speed. We want to get just-in-time preloading and speculative loading in place. I won't explain what they are in this video. We've talked about them in other videos. Basically, both these plugins have this. It's called preload or link preload or something like this. We use Flying Pages standalone plugin. It is free because it does just-in-time preloading, and it will do another type of preloading where you load a page and it will start loading every link on that page in the background. So the reason why that speeds up the time to first byte is, one, the pages get cached on the server. If they're not cached, we're sending requests. If the page isn't cached, the server will process it and cache it. And if it's ready to go, it sends the page back, so it's cached in our browser. So that will help time to first byte, and so will speculative loading. Speculative loading is a new version of this just-in-time preloading, or newish version, based on the Speculation Rules API. Really technical stuff, but bottom line, just get these two plugins and turn them on. But being mindful, it will jack up the load on the hosting, but it will improve the time to first byte. So you just want to make sure that you've got good enough hosting to support this. If you install them and the hosting starts falling over, then you know that the hosting has a performance issue or it's over capacity. These two here are usually not the reason why the time to first byte is bad, but they will improve the overall speed. So using the highest version of PHP the site supports, so requests are processed faster, and then using object caching, which is a type of database caching, which will speed up anything database related. So that's kind of the baseline. So if you don't have those in place, you need to get them. Those are kind of like the prerequisites for good time to first byte. Let's talk about troubleshooting time to first byte. And the article we have on our website is really focused on troubleshooting that. It's kind of covered a lot of things we've just talked about, like edge caching, HTTP2 protocol and things like that. But let's talk about the key problems we see. So the best way to have a look at time to first byte, if it's bad in the Core Web Vitals data, is to look at the server logs. So look at what's being loaded. So your web server or your web hosting has a log of every time a page is requested, and look at what's being loaded and if they have query strings attached. So if you have a URL with, like I talked about before, so if we have WPSpeedFix.com like this, let's just type it in, WPSpeedFix.com, and we have query equals blah blah, some sort of tracking string like that, that request is not going to be cached, and that page load is going to have a high time to first byte. So go into your server log and have a look at what's being loaded. There is a tool called Screaming Frog Log Analyzer, I think it's called, which can do this in bulk, but you can just kind of eyeball it, load the log in a text browser and just see what's being loaded. If you're getting a lot of query strings, then you either need to cache them so they are saved or stored in advance, ignore them. In this case, we would ignore this query string, so it would just serve the regular page, or you want to filter them, you want to block them. So if you have a lot of crawlers loading things they shouldn't, and a common problem we see is WooCommerce sites where you have crawlers loading a lot of add to cart and add to wish URLs. You want to block that. So you would block that with Cloudflare and the robots.txt file. And if you search WooCommerce robots.txt, you'll see our default robots.txt file that filters a lot of that junk. The most common problem we see is paid traffic with query strings like this that are bypassing caching. So in this case, if it was a query string related to paid traffic, usually you want to ignore them. You don't want to cache them because each one is usually unique. So you want to actually ignore them. So some scenarios you want to cache them, some scenarios you want to ignore them. So it's kind of technical, and I won't get into it in this video, which is which. But generally, if the query string is changing all the time, like it is it's paid traffic that's tracking the click ID or something like that, you want to ignore those. If it's something like a filter or a search in WooCommerce, then you probably want to cache those. So that's a different scenario. So just keep that in mind. Other scenarios we see is it logged in users that are slow. So if you have a WooCommerce site or a membership site with visitors logging into it, those pages won't be cached by default. So you want to make sure that caching is enabled for logged in users, and having these two plugins installed will help improve that scenario even further. So that's one if you have logged in users, WooCommerce and membership sites. The other scenario there that can be a problem is if you have a lot of staff logged into the website doing things. We've had some WooCommerce customers that have a whole call center that take calls and put orders through in the WooCommerce system for customers over the phone. And those users are all logged into the website. So in that scenario, that was a problem. So what we did to fix that is have the customer have all their staff or their call center staff use a non-Chrome based browser, so that data wasn't being pushed into the Core Vitals dataset, and the time to first byte dropped down because they were all using Firefox. So that was a weird scenario, but that's an example of a scenario where it might actually be your staff logged into the site doing things, making things slow. So just remember that those sessions count as well. Is it search pages that are slow? So there's a few ways to deal with search pages. We'll actually do a separate video on this, but a simple way would be to cache search pages. Another thing to do would be use a search plugin that is optimized for fast searches, but by default, WordPress search is going to be slow. Crawlers hammering query strings, filter with Cloudflare and robots.txt. We have a video on, I think it's called WooCommerce robots.txt optimization. It talks about that in much more detail. While it is WooCommerce focused, it is applicable for WordPress as well, but it's most likely, or more likely, a WooCommerce site will have that problem. And staff logged in, causing site, we talked about that. So that's it. I'll leave you with that. There's a few more troubleshooting steps in this post. For example, looking at using Query Monitor to identify errors. That can be another common issue if there's PHP errors or database errors. So give that a try if you're stuck. 404s can be an issue, so keep that in mind as well. Weird scenarios with 404s can create high time to first byte. JavaScript minification, CSS minification and combining, and HTML minification can in some scenarios cause high time to first byte. We recommend disabling all of that. Don't use minify and don't use combine. Doesn't do anything for speed and can introduce issues. Other things, WP config might have duplicate lines in there. That can cause a problem. If you go back and use this query string tool, query monitor tool, it will surface that issue as well. It'll surface as an error in there. And I think that's it. That's our video there on HSTS. So that's it for this video. I'll cut it off there because we've gone for a while, nearly 30 minutes. If you need help with your site, there's a few things we can do. you saw that reporting tool we have there, cwvreport.html. If you go there, you can run that report. It takes 5 or 10 seconds to run, no opt-in required. If you want paid help, we offer a free site audit. So fill out that form, takes 30 seconds. Tell us what you're stuck on, what you need help with, and one of our team will review your site and come back to you. And if there's anything else, just post a note in the comments and we will come back to you. Cheers.